So, hi you guys. Now the pitches at the MI5 Green and Smart Island Gran Canaria are gonna to start. So listen carefully and look for the new inventions of today. Have fun. I don't know. Okay. I'll show you later.
Guys, please come in front. Please come in front and be quiet. Quiet, please. So, when everybody's ready, and please take all the chairs in front.
Okay, guys. Hello. The back rows. Oiga. Wenig war. Can you pick up then? And you can come closer as well then. Okay. Sure. It works. You're not in the school. Well, there are still some left in the Okay, everybody on board? Well, I think our professor's here as well. Yeah, oh yeah, they're really important persons. You look really nice in your suit. Okay, well, welcome everybody to the final pitch. I would like to thank again to our great sponsors, especially to our greatest sponsor, AFK. Thank you so much. It was really a big help. Well, we have some other events as well for the near future. Okay, I would like to hand it over to you to give you the chance to send some words to the nice guys.
Thank you very much, Rainer. Guys, I personally feel more than honored
to have been with you the 2.5 days. I'm truly impressed by what I saw regarding engagement, really going into the tasks, trying things out, not having all the tools on hand that industrially would be available if one tries to do something complex or something new. But the one thing that inspires me, that I take back to Germany when I fly back tomorrow morning, is your inspiration to drive innovation. Yeah? There are things you don't know, your experience is not, let's say, the 30 years that we do have, yeah? But okay, 28. You're older than I am. Whatever you did in the meantime. Yeah, but you make the max out of it. Yeah? And this is what I take back as inspiration to my team in AMK, in Kirchheim. You don't know them too well. You have seen Jürgen. We are striving for records that you can see on our homepage, and we are owning a few records that are very, let's say, honorable in the industry. Yeah? There are records in Formula E students that you probably know, but there are also industrial records that we are striving for. I felt that my team is compelled by you, which is good, and which I like, and which I would like to confirm you in the way you're thinking about yourself, about team up, about doing things for the future, for a green future. I particularly support the idea of the green, smart green island that Rainer has developed, and I would like to see at least a few of you on my team at AMK soon. Thank you, Rainer.
Well, we will work on it. Yeah. Actually, if people ask me what we're doing, yeah, we as ITQ, I always say we are producing young people, well, in an innovative way. Well, I have a quite good perspective here. I see a lot of young people, or still young, or which try to be young. Well, but now I would like to hand over to the first pitches. I don't know who will come, but probably you will know it. Yeah? Okay, then I hand it over to Stefan.
Thank you, Rainer. Before we start the first pitch, I would like to say some facts, because we are all, well, engineers, kind of engineers. We like facts, yeah, that's true. It's a fact. So, at this Makeathon, we had 73 students coming from 19 universities out of 12 countries. And not only 12 countries from Europe, we have one team coming from Colombia, South America. Maybe give them a big applause for the... Yeah, so please stand up. Great. So, and additional to these students, we also had 28 professionals who also participated at the Makeathon and hacked and made and, well, had a lot of fun with all the other students, I think. And additionally to the Makeathon, we had 27 students at the robotic workshop at the last 2 days. So we had about 140 people all over, I think. So a really big event here. So another fact, and that's the last one, we had 3,000 soft drinks, and more important, we had 1,300 beers. Okay, so on Friday, some industry partners presented some ideas, so for the teams who had no clue what to do, and they presented some problems out of the industry. And additionally, teams could also pick up some own ideas, and the first team will be team tracking, and they picked up the industry challenge by Mitsubishi Electric, so maybe please come in front.
Hello. Well, we are team tracking, and this is our final pitch. So our problem was basically that we had this production hall, and in this production hall there's a robot which is guarded by a safety eye. So what we wanted to do is we wanted to know if there's a person in this production hall, and we wanted to know if this person is heading towards the robot. So what we did was we found a way to triangulate a person's position and then to predict their way of movement using their previous positions and their velocity. Well, why are we doing this? This quote from the New York Times tells us that there's around 1 fatal accident per year in human-robot interaction. So, to minimize the risk of an accident with a robot, we need to make our control and our system smarter, and we think that our solution is a step in the right direction for that. Well, here you see our interface, and what we have done is basically, you see this blue line here, and this line is actually a vector which indicates the person's speed and the direction they're moving in. And how it works you will see now in this video. So what we've done here is we've created a little test environment right down there, and on the top right corner you can see our predicted movement and the position of the person walking. So yeah, that's basically what we did the last 4 days. This is the team that did all this. Big applause to them. They're sitting right here. What we are trying to do next, or what we thought about doing next but haven't gotten to yet, is we wanted to extend our resolution with data fusion, meaning that we connect our gathered data from Bluetooth and from Wi-Fi to increase our accuracy. Also, we wanted to develop a self-learning algorithm to improve our accuracy. We wanted to improve our prediction software to know if a person is maybe walking in circular motion, and we want to use it for indoor navigation. Thank you. Thank you very much. Yeah, big applause. So, are there any questions from the industry partners, from the professors, from any other person here?
I think the professors certainly have a question now. Dirk? No? Okay. Well, any other professor? Erich? Alright. Okay. Okay.
It's better Wi-Fi or Bluetooth?
Sorry, what?
It's better Wi-Fi or Bluetooth for training?
Wi-Fi. Wi-Fi is better, definitely.
Why?
Because Bluetooth has
Sounds
a
better.
very long reaction time, and it's not as accurate as Wi-Fi.
Okay, no more question? Ah, there. Ah, there's a professor. Huh? He's here, but I didn't see him.
So this is our team, that's why I have to ask the question. What is the idea on machine learning algorithms you have as a future outlook?
I mean, we haven't had any special ideas yet or formulated our goals, but we thought about the opportunities given to us through this project and what we should do if we want to implement it permanently, like in the situation given by Mitsubishi.
Okay, thank you. Great presentation. What I forgot to say, the pitch time is 2 minutes and 30 seconds. You can see it here, so the teams have to stick to it. And, well, he managed it really nice, so I think there are also about 5 seconds too much, but that's no problem, I think. So the next team will be Team SDS. SDS stands for Smart Delivery System, and they are from Optima. So, who will present?
Okay, so good afternoon, everybody. Thank you so much for your presence here. So we are the Smart Delivery System team. And I hope, yeah, that's it. So we are the Smart Delivery System team. And this is our presentation. We start, of course, with our motivation. So just-in-time production is needed in efficient warehouse transportation. So every day, OEMs need to deliver parts sustaining in the warehouse to the production halls. And the employees, the workers on these assembly halls, they have to receive these parts. So our solution is, first of all, an Android app to interact with the warehouse and autonomous vehicles to transport the parts that are coming from the warehouse. So this video is actually a video from our prototype, which is going to show you how it works. So this is our server. So this is our autonomous vehicles. It is standing on the warehouse. Sorry for that. Okay, it seems. So we have an app. On the app, the employer is able to actually inform the project number that he's working on and also his employee number. He can request parts, such as this one, not exactly as this one. And this part will be delivered to the project which he is sustaining. So once he receives the parts, he can confirm that we received the parts, and the vehicle will drive back to the warehouse or wherever it has to go later. Yeah. So benefits. First of all, save employee time. We made a small research on our factory where we work, and we believe we can save up to 2 hours per week per employee. And increase efficiency of project assembly. We believe we can increase up to 10% the efficiency of building up the projects. Main features. So these are the main features we have. So we have Android app as a user interface. We have a Raspberry Pi 3 as our MQ22 broker. And we have a ESP8266, which is a microcontroller with Wi-Fi built-in as the vehicle controller. These are our team members. So they are standing here, so please applause to them as well. and Outlook. So we are supposed to enhance the app user interface, create ERP interfaces, and also extend the software to control several vehicles. Yeah, that's it.
So, are there any questions to Team SDS? Any questions? No? Then I think we will go to the next presentation. The next team will be Team Connect.
Hello everybody, I'm talking to you from Team Connect. We've seen that in the industry of smart homes, there's currently a lack of cost-efficient systems that you can buy as a user that incorporate the use of gestures, and we thought that we might be able to fill that loop. So our solution to this problem is supplying a cheap method for you to control all your devices in your house and also be able to use your hands and feet to try to make your devices work like you want them to. And we found a way of constructing a device that is way cheaper than what you currently can buy on the market. The average price is around 50 euros per device, and you usually have a subscription that's added to it in a monthly way, so that you have to pay an extra 6 euros per month. And we thought that it would be a better idea to supply the service of monitoring your devices for free once you've bought our product for maybe a suggested price of 20 euros, considering that we can produce it for around 9 to 13 euros. And I'd now like to show you some of our footage. You can see our apps on the left side and also a prototype of the main hub in the top right corner. I'm now going to move on to our gesture control, which took us quite some time to figure out. As you can see, we've managed to control some appliances in our house with the use of either a Myo handband, or if you own a Kinect device, you can use a Kinect, hook it up with our system, and control any sort of device that you'd like to control in your house. So here's the prototype in action. We've 3D printed the casing and used what we had available to us. We're hoping that in the future we can also implement our technology in the industry and try to possibly make medical engineers or medical professionals use our technology as well, and possibly make an all-in-one home controlling system so that you can enjoy your home appliances in a very convenient way. I'm now going to show you some pictures of the hardworking team, and I hope you appreciate our work. Thank you. If you have any in-depth questions, please mention them later in our hub. Thank you.
Okay, thank you. So, are there any questions directly? Any questions? No? Okay, I think that you had a quite good slideshow, so everybody got the point, it seems. No question. There is a question.
You know, guys, you've showed a business case connected to your idea already. So what's your plan?
Well, if this ever does go into production.
If this does ever go into production, we're hoping that we can make cheaper circuit boards so that we can supply the smart home hub for a price of 20 euros. That would be quite a share for us to get a profit from, since we can produce the components quite cheaply. And we think it's more fair than pushing high prices on you just because you're being given an innovative technology. So I think that's what we're trying to achieve with our business idea.
Okay. You want to be in that business?
I hope so. That would be great.
Okay. The next team didn't pick up industry challenge, they picked up 2. Because Francesco from Grupo ASA came here and talked about his companies. He has 7 companies in Europe, and then Siemens came here and, well, had some kind of a maybe solution, and the students connected both industry challenges. The next team will be Team MPS, Make Productions Simple.
We are in the age of information, but we are not using it well. We're overrun with data, but are we using it intelligently? Are we analyzing it? No, we are not. Francesco had this factory, 7 factories around the world, around Europe, and he has so many machines, so many data, and he does nothing about it. Francesco's sad. We have a demonstrator of something that he has in one of his fabrics. So the cans, good cans, show a green light, and red cans show a red light. This is for the quality manager, of course, because what does the top manager care about if the cans are good or bad? He only cares about if he's going to have enough profit to buy his new Tesla. So what we're doing is we're integrating a solution for Francesco. We come from the prototype to his company to the big data. And how do we do it? With Siemens. So this is how we integrate the companies. We put the data into the cloud, and from the cloud to the app, which sends it to the right person. Here we have a diagram of our pyramid managerial strategy. The operators care about their information. The quality operator, we call that Francis Qual, and she cares about the information about this quality thing, not other temperature sensors. And the top manager, you already know. This is how the app would look for the quality manager, Francis Qual. She has a traffic light. This is very important because it's a visual information. She's going to know whether she's doing her job well, green, or red. She has to solve a problem. She's going to see the data in an organized way. She's not going to waste up time doing graphs, sending reports. She already has them. She's doing her job, not somebody else's job. She can address the job on time, reactivity. So we customize a solution for Francesco. We can upscale it easily to 1 plant or to 7. And we can save time. You know how the rest goes. Save time, save money. In Francesco's case, this goes up to 100,000 euros per year, per company, per factory. And he has 7 of them. 3% efficiency in direct operations, 0.5 in rejected cans. So we integrate MindSphere to, which is the security, to an innovative, customized solution. So right now we have a prototype, then we're going to implement it in Grupo ASA, and finally we can upscale it to get our startup going with the aid of these 2 partners. Thank you. This is our introduction.
Are there any questions maybe from the industry partners? Are there? Questions? No?
Did Siemens already license the solution? Did Siemens license the solution?
So the standard solution, of course, is already licensed, but not the really great things the team built up. So you have to talk with them.
Okay.
I have another question. Will Siemens enlarge our budget? Old man. Old man. That's not probably his excuse. There's Christina. She's much younger. Okay, did you hear it? Okay, good. Well, we will talk about it.
Okay, next team.
Okay, the next team is Team Kostwein, coming from Kostwein.
Hello everybody, I'm Philip from Team Kostwein, and I need a stick. So, we got a problem, or a lot of companies have a problem. They have their production hall, they have a lot of data, but they don't know what's going on in their production hall. And so, we built a solution for that. No, I don't know. Okay, here's the solution. We pick up all the data, get some more data from the Raspberry Pi with some sensors, with a webcam, and build a dashboard where the manager or a maintenance guy or something like that can see everything what's going on in this production hall. Now the video, please. So you can see the video. Now the camera is turning, and you see that we moved something up to see that the lights going down are on and going off. And you can also see on the floor plan. And you can see on the dashboard a lot of information, which you can see more details, more graphs and something like that. A lot of graphs actually. You can see what's going on in the production hall. The lights are turning red or green if the machine is going or running or not. You can see that you got a problem. Where's the problem? Okay, it's the machine. Now what's going to happen? Someone is coming, next repair. He's going there, you can see that he's there, he's repairing, he needs 20 minutes, now it's solved. So, back to the slides, please. So what do we do? We take a lot of open source products like the MySQL database, the Zabbix for monitoring, the Ubuntu on the Raspberry Pi, Raspbian, and on VM, and we took the framework Bootstrap to build a dashboard or to build it easier. We chose cheap hardware, and I got 10 seconds. So my team, Marcus, Michael, and Philip, you can read what they are doing. The outlook, we want to track everything what happens in a production hall, or at least what is allowed to track. We want to use as much open source as possible and keep everything modular. Thanks.
Thank you very much. So, any questions between Kostwein? Questions? In the back? No? Okay. Then nothing. Thank you once more. Okay. Next will be Team Remote Planting.
So, hello everybody to our small team Remote Planting. To state our problem that we faced, we have to tell a sad story. So, there's a car driving, and just in the moment somebody is coming and he gets hit by the car. So, what's the problem of Bob? Bob is disabled now, so he wants to do something. What can we do with him? He was a very good worker, so how can we save his workforce? We thought of maybe we can make a system with which he can plant or do something else without getting into directly touching the things. For this example, we try to produce a remote planting. So we have a sensor that where he can put his hand over and he can control the robot here. Here's the sensor. Yes, and that's the first little movement of our robot without connection, directly connection. It's over VLAN, so yeah. Bob could work now. Maybe some grabbing or something. So, what's the impact of this? We don't have to say it. Everybody could work if we had some robots in the field, and we don't have to get into the field. Workforce would be saved and not lost. Yeah, the team was Dominic and Marvin. Dominic was responsible for the hardware, so the robot. Marvin and I did the software implementation, and yeah, that's everybody. Did I miss somebody? Paul? Dominic? What's the outlook of our project? We have to do some more developments. You saw that the robot is a little bit slacky. So we have to do some more research on the positioning. We need stronger motors, implementing exact hand movements, and you need tools to do something. So to put some weeds on the ground or something, you need tools. So we have to do some more research there. Thank you.
Wait for the questions. I hope there are some questions now. Yeah? No? Where's Marvin? Yeah, where's Marvin?
I'm sorry, I switched some people. So this is Marvin. This is Paul. And Dominic is already in Germany, I think, so he's not here.
Other questions? No? Then thank you. Next will be Team MRS. They were sent here by the company Excelgo, so they're still students.
Yes, we were doing mobile robot simulation in the virtual software Excelgo provides us. The problem we tried to solve with this was that a large percentage of making a factory is debugging code for PLCs, and the solution for that is build a virtual environment with sensors and actuators and give that as input for a real-world PLC so we can program it offline. That means we can do virtual automation models, so we can simulate a large part of the ramp-up phase so we can start producing faster. And this here is what we did. In a few seconds, the mobile robot located here should hopefully start moving. And all of this here is done real time. That means the robot here it won't assume anything. The only thing it will do is act to the surroundings that we have put up here. So a human could walk in front of it and it would adapt to that. The advantages here is, of course, to reduce the ramp-up time. We can predict bottlenecks of the products we make. we can see bugs in the code, how they react to the environment before we start ordering hardware and implementing it on a existing system. And we can see if we have some weak points, for instance collisions and such. Yeah, a distinctive feature for this one is that it's real time, so the simulation will not run the exact same program, or the robot will not have to do the same motions all over. It depends on the environment it's in. The team, I did about 50%, along with Stefan did the other 50%. And I think that's it.
So I think the first question will be, where's Stefan? So please stand up. Okay, are there any other questions to them?
How easy is it to connect? How easy is now to connect Excel Go with the ROS? It should be.
It should be fairly easy. It depends how you build your robot. But if you build it with Excel Go in mind, it should be easy.
Other questions? How much processing power does it require to run the simulation?
It depends entirely on what factory you simulate. This one here was probably the limit for my computer, but that doesn't say much.
Okay, thank you very much. So, next will be Team S Water. And while they come here to the stage, I will just switch the batteries. The rechargeable batteries, of course.
Good evening, everybody. I warmly like to welcome you to the pitch about S-Water, a smart, efficient watering system for eco-farming. Well, it's too quick for me. The issue is water is an issue. It's an issue already now, and the issue will become bigger in future. As Forbes estimates a population of 9.6 billion people in 2050, so we need to treat our water supply carefully. So therefore we thought, well, it could be cool to make a smart watering system. We call it the S-Water, so smart, S for smart, and water is self-explaining. So this was the concept study at the very beginning. So after 4 days, this was the outcome. So therefore, I would like to ask Stefan to play the video, please. Oh, you're taking my time, but I guess we will handle it somehow.
Gran Canaria, testing our water robot. The robot goes in the area, sense the humidity of the soil, and send the information back to the server.
The server received the information from theoretically different robot, and with a logic calculate the area that really needs water, and then send command a position for watering the environment. So now the robot knows which one it moves. It's go down with our motor confines your communication, and you can pump the exact amount of water that's needed for this plant.
Okay, thank you very much for the applause. And these are the people behind S-Water. So I'm actually an electrical engineer. I was looking after mechanics. We have some informatic guys, some electronic guys who did the program, and we really had some good 4 days and lots of fun. The impact will that we will support the initiative Green Island with our product, and the outlook is GPS integration, pH level measurement, integration of a smart fertilizer dosing system, improved algorithms on the historical data, and smart online training of the device by the farmer, just going around with the mobile phone. And as it will be a very big step, we call it S-Water 10.0. Thank you very much for your attention.
So, any questions? Maybe on the robot?
Well, pretty self-explaining video, so.
Yeah, it was nice to see some self-driving robot here.
Autonomous driving.
Autonomous driving, yeah, of course. So, any questions to him? To the group? No? Okay, then we will continue with the group Smart Urban Farming. So we're the Smart Urban Farming group, and we had a problem. So maybe you like agriculture, maybe you want to plant, but you're a working guy and you don't have time. You travel all around, or maybe you're a student who's working for finals and don't have time, or maybe you don't have space in your little balcony in the city. Well, we have the solution for you. We have the Smart Urban Farming Pot. This is everything you need to make a little agriculture just on your own little balcony. So the impact, well, thanks to this little device, you're going to be able to have greener cities, and people who are living in urban environments will be finally connect to nature as they wish, and they will have the joy to eating their stuff that they've grown in their own little balconies. Well, first of all, it's an entirely autonomous, self-sustaining farming pot. We have solar cells powering everything, and if there's something going wrong, we also have a little backup battery that can alleviate that problem. Second part, we have an automatic irrigation and fertilization system. Depending on the data received from the sensors, it will automatically water the plant, or it will, depending on the growth cycle of the plant, it will automatically add fertilizer to it. Could you please play the video now? It's the bottom one, yeah, let's do it.
Yeah, I'll stop.
Whatever, it's fine. It's basically showing how the irrigation system works. Well, could you possibly play this one, maybe?
doesn't need to be full screen.
You don't see my mouse.
It's over here. So basically, from the information gathered from the sensors, there's two different covers. One is the greenhouse effect, and the other one is sun protection. So if it's too cold outside, you're going to see the greenhouse thing come down, and it'll increase the water, the heat temperature, and the humidity inside. And if it's too cold, you're just going to see the other thing that is for sun protection. We also have a little app that does all the real-time monitoring of the flower pot conditions, and you can just go into this app and see all the different values and all the last irrigation times and fertilization times over here. And it's all customizable depending on the plant. So if you have strawberries, you can do something different, and if you have cacti, you can do something entirely different as well. So our vision, in the future, we're gonna, if you do have the opportunity, we're gonna have different sizes, and we'll also have a live weather data input for automatic function. And we're also planning on tracking growth to have better understanding. And we're also planning on making an on-demand photo of your plant using the app so you can see it wherever you are. And this is our team. Thank you very much.
So, are there any questions to smart urban farming? No? No questions? Yeah, that's one. Yeah, thank you.
Have you thought about using big data for measuring the farming success in New York or so?
No, actually, we didn't actually have time to use like all the data that's gathered like around the world. So we just made like what we could in the time we were allowed. But if you can fund us, we can definitely do it for you.
Thank you. So, the next 3 teams. Thank you. Question?
How much will it cost?
Well, I would assume it's around $50. Yeah, like everything included. But since it'll be like automatic all the time, well, it'll cover its cost in like maybe 4 or 5 cycles, I guess. With all the organic food you're getting and all the prices of the organic food, which are crazy. Thank you.
So, the next 3 teams, they all picked up the industry challenge held by Professor Daniel Hernandez, so big applause for him. So Daniel is working on an autonomous sailing boat, and he had some different visions, so different visions which could be picked up, and the 3 teams, well, had some 3, well, other functions of this vision, and the first team will be Team Kite to Motion.
So, good evening everybody. In the name of Kite2Motion. As you told, we have a project here at the University of Gran Canaria, an autonomous boat. You can see it on the left side. It's the second prototype, which has 2 sails that could be going to some different positions. But in the case if you want to go with the wind, the planes are facing each other, so you have just less area of sailing, and therefore you only generate less drive. So we want to build a system that uses this energy more efficient and to generate more drive. Therefore, we did on the one hand a wind measurement unit where you can detect the direction of wind and the speed of the wind, and on the other side a unit that could raise up the sail if the conditions are right, and pull it back into the socket if it doesn't have the right conditions, and sets the sail positioning right for the current wind conditions. Yeah, happily it's not really windy in here, so we have a little video. As you can see, more or less, when the wind started to spin, the sail goes up, and as we... Just 1 second. Yeah, and it's probably too short, but if we start in the middle, the sail is back, going back into the socket. Yeah, so we have mainly 3 teams. The upper team that have built the whole wind measurement unit. The middle team built the whole actuating parts for moving the sail up and down. And the bottom team, we built all the rest of the prototype you can see down here. So, what is this all good for? The shipping industry causes about 4% of the global emissions every year. While this number doesn't seem very big, the total emissions nearly doubled in the last 30 years, and they are expected to double again in the next 40 years. So we have to supply a cost-efficient and easy-to-use solution for the industry to cut those emissions. Thank you.
Any questions to kite to motion? Maybe Daniel from you? Any question? Oh, so he's happy. Yeah, that's great, isn't it? Okay, then I think, yes, thank you. Okay, the next team which picked up the industry challenge will be Team Sailing.
So we're from Team Sailing, and we faced the problem of an open loop sail positioning controller, which can lead to a confused captain on the boat. So our solution is a closed loop sail positioning controller based on a redundant sensor array, as you can see on the bottom of the slide, and hopefully a happy captain. The solution is implemented on MATLAB and Arduino, so the hardware is running on Arduino, and on MATLAB we're doing some image processing, and also the graphical user interface is on MATLAB. So here you can see a small video. On the left side is our mock-up of the sailboat. You can see the sail changing position when the set point is changing. And in the graphical user interface you can see the set point changing and the measurements changing according to the set point, so the sail actually reaches its position it should reach here. So the impact, well, with our solution, hopefully the team with their autonomous sailing boat will be able to cross the Atlantic, and maybe they will end up on the first place in the competition. That would be great. So inside the boat it looks like this. We have on the left side a resistive sensor, which is directly connected to the sail motor, and on the front side there's an optical indicator, which camera captures pictures, and then we do some image processing where we get a sail angle, and in the end we end up in a redundant sensor array, so we have redundant information. That's our team. So it's Jonathan Huni on the left. He did the control algorithm and the graphical user interface and simulation in MATLAB. Patrick Reed, that's me. I did the image processing algorithm and built up the cardboard mock-up. Yeah, a small team. So Outlook, yeah, hopefully the team of Gran Canaria can implement our algorithm in their sailing boat. And yeah, for more information, just check out the link here at valerorobot.blogspot.com. So thank you very much.
So, any question to this team? No? I think the audience is a bit shy today, but I think they're very interested in all these prototypes, and after the last pitch, which will be right now, there is the possibility to visit all the projects on their stations. So you can visit them, have a look at them, and maybe even try something out. So, but is there any last question? No? Then we come to the last team, which will be Team Rainbow.
You could think that I'm a funny guy with funny music and stuff, but today I actually came to you to talk about something very serious. That is the pollution of the seas, which is getting worse and worse every day. It's not just disgusting for surfers, it's dangerous for the wildlife, and it's just really, really not good. Our solution was to build a catamaran that is entirely green and powered by solar energy that can go and collect garbage. I could. I noticed there was something wrong, but I didn't know what it was. Okay, and this boat, it will be super awesome. It can detect the garbage, and then it goes there and catches it. It just has a net under its surface, where it can go everywhere and just catch basically everything that isn't too big. And the problem is, well, that's what we would want to do. I forgot to say that. I stole it from some politician, the quote. And, yes. So to make the solar power possible, it's important that we have a floating dump station where the boat can bring the dump and also change its battery, which is already charged by the solar panels. Also, we need to make it smart enough to, basically know where the trash is and go there. Well, the last part is a big applause to our team. We have a lot of fun last year, and that's a lot of fears, and still want to show you the colors. This was really it's because we want to make our planet clean and green and the water as blue as possible. Thank you very much.
So, is there any question to the last team?
Why is the color changed?
Okay, the question was, why did the colors change?
That's a hard question. Actually, it was just a design choice because red seemed kind of aggressive, and it just doesn't fit to what I wanted to say now. So. But it's very observant that you noticed it. Any other questions, just come to our place afterwards and we will tell you about it.
Thank you. So, I think we have to give one really, really big applause for all the teams, for all the presentations. So I will hand over to Rainer again.
Okay, well, your last slide was Outlook, and therefore my last slide are next steps. Okay. Did we get it out soon? Almost. Well, okay, really, really great. I think we are really stunned. The young, old ones are really stunned. I really appreciate what you did in the last 4 days. If we look at the real life and industry, well, in 4 days, it happens nothing. If you are in a big company, in a middle-sized something, in a small country, a lot. Well, and I think this is exactly what we need. It must happen more in a shorter time, and therefore these Makeathons are really cool. Well, and now the next steps are, well, I've got an email today. Yesterday there was the consejero del Cabildo, the consultant of the Insel president, island president. Well, and I've got an email that I will have an appointment with the president of the island on the 3rd of March. I think it's not that bad. Well, even if you have in mind that the first touch on this island was on the 14th of April, that Jonas, which was the first student, which I put on a Robinson Crusoe project, and less than 1 year afterwards, we have this huge amount of people here, and an appointment with the island president. Not that bad. Okay, and then to go on, we have already some other events in mind. The next Makeathon, hopefully, well, we struggle still a little bit with the old ones. We have there in Klagenfurt with Kostra and in the World Class Manufacturing Circle a huge group of old men, like me. Well, and it's a little bit hard to express what is a Makeathon, what is a Makeathon, and therefore we struggle, but with Philip and with Michael, hopefully we can convince some of them that they will join us. Then around 6th of June, I decided we will have such a workshop of deep learning here in Gran Canaria. Well, I don't have an idea what we do exactly, but we will do it. Then this is the next date is quite clear. On the 27th and 28th of June, there will be a Makeathon at the Laser Fair in Munich. This will be about 36 hours without sleep, because hotels are really rare at that time, and therefore we have to skip sleep. Then in August, where is my friend Thomas? We talked about there might be a happening for kids and young talents in Shanghai. Okay?
98%.
98%. Well, okay. Well, at the end of August, there might be a Makeathon in Bogota. We need still some sponsors. And at the end of September, there will be the summer camp for the MI5 car. Therefore, we need some motors and some money to do this as well. Well, the challenge, no problem for us. We have a lot of challenges. We have more challenges than money. Okay, well, these are the next events, and well, our overall goal, and therefore I need the next slide. We need your help. As I mentioned, we started less than 1 year ago, and our goal is to think big. We want to really build up an international network of young talents and still young talents, and therefore we need your help from everybody of you, and therefore there would be one task for everybody of you. Tell minimum 3 friends what you experienced here, that you had to drink about 1,300 beers. Well, I had with this funny guy. Where's the funny guy? Mr. Chewing Gum? Here. I asked him to tell his friends what he experienced here, and he said, "Oh, here's Freibier." Well, this is the major information that there is Freibier here. Next time we have to talk with the brewery, which is right around the corner, that we get the beer. Well, I think, no, this is really, really important, that you tell everybody, minimum 3 persons, that it was cool and that you learned a lot. Okay, even better. Even better. Even better. No, because, well, to make not America, the world great again, I think this is really important that we have different generations, a lot of different disciplines, a lot of different nations, and all this silly stuff which is happening right now all over the world. We have to do something. And you're the youth, you're the future, you can do something for your future. And therefore, I really, really would appreciate if you help us and tell that it's cool and that it works, that people from different nations, from different countries can work together and work and live in peace and harmony. This is really a big wish of mine, and I would really appreciate that you help me to build up this international network. Okay? Thank you so much. It was really great. I'm really proud of you, and it's a really good feeling to stand here and see you all here. Thank you.
I just would like to take the opportunity, well, just was quickly asked if I want to tell some words, and I hope, or I guess it's, well, everybody's happy that, well, I think we just have to say a big thank you to Rainer Stetter and his team. They have done a great workshop here on the Green Island, on Gran Canaria, and also together with the government here from Gran Canaria. And I think we should give them a big thank you, and yeah, just give them their applause for they deserve. So please come to the front. So all the people from
around. Because you made this great project possible. Big thanks to all of them.
Thank you very much, and enjoy the evening.
Okay, well, I have to really to thank my team because I have always the silly ideas. Well, and they have to survive somehow. It's a quite cool concept, it works quite well, and really thank you.
So, what's next will be, all the teams can now return to the islands, and hopefully all the other people here, who are around here, take a look at the prototypes, let it explain to you what it really does, and maybe try it out on yourself, and, well, have some fun. Yeah, thank you.
Ich glaube, so viel ist da jetzt nicht mehr.
Do something funny.
One more time, please.
Wait. Good. Thank you. Ja, euch auch ein Bier hier.
So, thank you for watching the MI5 Gran Canarian live stream. I hope you had a good time and see you soon.